In this question, we have to find I1 and Vs. So what is this I1? It is the current which is flowing through this 2 ohm resistor. Vs is nothing but it is the voltage across this current source. You know that this is an independent current source and it is delivering 6 ampere current. So that value is fixed here. But we don't know what is the voltage across it, right? So we have to find that one also. And here there is a 20 volt source, okay, 20 volt source. So remember this. See, to find the current I1 or the current through this 1 ohm resistor, we don't need this 20 volt source. Okay, we won't consider that because directly we can apply the current divider rule, right? This is 6 ampere current. So I can apply the current divider rule because both the resistances are of known values. So now what I can do is to find the I1, I can apply the current divider rule. So total current, that is 6 ampere. The resistance in the opposite branch, that is 1 ohm, divided by the total resistance, that is 1 plus 2, that is 3. So I1 is equal to 2 ampere. So now we have found out the value of I1. Similarly, if they had asked you what is the current which is flowing through 1 ohm resistor I2, so what you can write, I2 is equal to 6 minus I1, that is equal to 4 ampere. Or if you want to use the current divider rule, you can also follow that. Okay, so this one will be 4 ampere. Using current divider rule, this is directly using this because this is the total current. So if 2 ampere flows here, so out of 6, 2 here, 4 will be through the 1 ohm resistor. So 4 ampere is the current that is flowing through this. So now what we can find out V1, right? We can find out V1. How? Using Ohm's law. We know I1, we know the resistance value. So I1 into 2. So what is I1? It is 2. 2 into 2, that is equal to 4 volts. Okay. So V1 is 4 volt. If V1 is 4 volt, what is the voltage across 1 ohm? That will also be equal to 4 volt because these two resistances are in parallel and in parallel the voltage will be same. So now what we can apply the KVL, right? We can apply the KVL. Now we will consider this 20 volt source because we have to find Vs. So Vs, I will always consider, means if I am going like this, if I am getting minus, I will consider it as plus. If I get plus first, I will consider it as minus. Okay, so Vs, and here I am getting plus, so it is minus V1, and here it is plus, so it is minus 20. That is equal to 0. So Vs equal to 20 plus V1, and what is this V1? It is 4. It is 4 volt. So 20 plus 4, that is equal to 24 volts. Okay, so this is the value of Vs. We know the value of I1, V1 and Vs. So this problem is completed. So let us move on to this question now. So here they are asking you to find the value of IL. First part, I am taking only the first part to find the IL. Okay, how can we find IL equal to V divided by R equivalent? So what is this R equivalent? That will be these two are in series. 2 ohm, 4 ohm are in series because the same current is flowing. So R equivalent will be 6. What is the voltage value? It is 6. So it is 1 ampere. So the current which is flowing is 1 ampere. Now they are asking you in part B to convert this voltage source to current source. So we have to convert this to current source, and you know how to convert voltage source to current source. So this is the plus, this is minus. So you know internally what will be the direction of the current? It will be directed towards the positive terminal. So here we have V divided by R. What is V? It is 6. What is R? It is 2. That is 3 amperes. So now we know that the resistance value does not change. So that will be 2 ohms. And here this is the terminals. And here I am connecting the load resistor. That is 4 ohm. So this is how we are going to convert the voltage source to the current source. Now again in third part, that is the C part, they are asking you to find out the IL and compare the result. So here this is IL. What is IL? Using the current divider rule, it is 3 into 2 divided by 2 plus 4. So it is equal to 1 ampere. Right? So this is also 1 ampere. So in the first part also we got 1 ampere. So if we are converting the voltage source into its equivalent current source, the current does not change. It remains the same. So that will be 1 ampere current.